Welcome to Lecture 2.1 in Growth and Motor Behavior. And this lecture is going to cover Chapter 3, which talks about the principles of stability and motion. These are principles that are common to biomechanics, and the purpose of this lecture is to relate these principles to growth and motor behavior. And since all movements occur in a concept that is governed by the principles of stability and motion, it's really important to study these, especially when studying development. Basic outline, we're going to go over physical and mechanical principles, Newton's law, the force versus distance relationship, stability and balance, as well as detecting and correcting errors. When movers are initially performing motor skills, they tend to work against the principles, and as they increase their proficiency, they begin to use these principles of physical and mechanical stability to their advantage. So development involves constantly calibrating movements to exploit physical and mechanical principles. And changing bodies such as longer limbs or stronger muscles, and environmental factors such as friction and gravity all play a part in shaping the motor skills. And during development, there are many organismic constraints that change. And as a result of the constant changes taking place in the body during infancy and early childhood, seemingly inefficient movement patterns may be efficient given their size, shape, and strength of the children. And it's really important to understand the contribution of these factors when examining the changes taking place both in the body as well as the changes taking place in the motor skills. So the first principle that we're going to discuss today is Newton's first law. And an object at rest stays at rest, or an object in motion stays in motion until acted on upon a force. So this is pretty straightforward, but in terms of motor skills, you need to apply a force onto an object, such as a ball, in order to make it move. Or if a ball is in motion, you need to apply a force to it in order to change the trajectory of movement. So I think it is a little bit challenging to apply this to a motor skill setting, but you kind of have to think about it as if you want something to move, you have to apply a force to it, and if you want to change the way something is moving, you have to apply a force to it as well if it's already moving, or you have to apply a force to it to get it to stop. Newton's second law is basically saying that force equals mass times acceleration. If you have two objects with the same mass, and you apply more force to one object, and you apply less force to another, the object that you apply more force to will accelerate further than the object you are applying less force to. You can also affect the mass of an object and see this principle in effect. So if you have two objects, one is less massive, one is more massive, and you apply the same amount of force, you can see that the more massive object will accelerate less than the less massive object. And we can use these principles related to force in order to better maximize our performance based on the equipment that we're working with or what exactly it is that we are trying to move. So a way that we can really apply both of these principles is the force versus distance relationship. Since there is a relationship between the force applied and the distance over which you apply the force, we can see that when you're throwing a ball, the child on the left applies less force than the child on the right because he is exerting the force over a shorter period of time. When the force is applied over a longer period of time, the ball will travel further. What is important to keep in mind is that there is an optimal relationship between force and distance in most motor skills, because just increasing the distance of a given force will not automatically result in improved performance. So many times when children are learning a new motor skill, you'll see them exploring the nature of this relationship so that they can best manipulate what is the ideal amount of time over which they need to apply a given force. Newton's third law is that for every action, there is an equal and opposite reaction. Meaning that if you exert a force on an object, the object exerts a force back onto you. And people need to take this into account when performing tasks, and in certain sports such as diving, people can use this law to their advantage. You can see here in this example that the diver is applying a force onto the springboard, and the springboard applies a force back onto the diver such that he or she is projected into the air and then will subsequently land into the pool. Another example in which this concept really comes into play is the oppositional arm swing seen in walking. So you see, as an individual swings their foot forward, there's an equal force put on the individual that comes backwards. In order to counteract this force, a person will swing their arm in the opposite direction, which counteracts the forces. So you can see that you have multiple forces in play, and you're able to maintain your balance because you are using the forces to your advantage. We'll stop this part of the lecture right here, and we'll continue the lecture into the next video.